we're gonna review these last two sections. We already covered them. Oh, thank you so much. It's section 8.8, 8.9, the last two sections of chapter 8, the last two sections of factoring. And is this the hardest two sections? Heck no, it's easy. What we're doing on these two sections is factoring perfect square trinomials and binomials. Okay, so how do you know when you have a perfect square binomial? Well, here's an example right here. Let me zoom in so you can see it. How do we know that's a perfect square binomial? Well, you have a perfect square term here, and you have a perfect square term there. How do you know there's a perfect square trinomial? Perfect square term there, perfect square term there. However, this just qualifies for you to try this shortcut, but you still need to check your answer once you factor it. I would still distribute and then combine like terms and see if it actually works out. So let's read along these notes right here. It says, if you have a perfect square term in the leading term and ending term, then maybe you have a perfect square quadratic trinomial or binomial, in which case you can take the square root of each and plug it into your answer format. So when you do have 25x squared, when you take the square root of that, that's 5x. When you have 36, you take the square root of that, that's 6. So you're going to have 5x and 6, and check it out, here it is, 5x and 6, 5x and 6. So since we have the same first term and the same last term, when you do the square roots, you also get 5x and 6. The only difference is on a binomial, you have to have different signs in order for the middle term to cancel out. On a trinomial, you have to look at your middle value, and that'll determine whether you have plus plus or minus minus. Now, because it's a negative, they both have to be negative. If this would have been positive, both would be positive. We know they can't be different because if they're different, when you distribute, the middle term cancels out. You end up with a binomial. So if you have a trinomial, they either have to be both negative or both positive, and that middle term will tell you whether they are negatives or positives. So let's take a look at yesterday's worksheet. Let's take a look at number 12. We did the odd ones, and I already put a video explaining all the odd ones. But let's just jump around here. Let's take a look at number 12. Is that a perfect square binomial?
Yes.
Not yet. No, it's not a perfect square binomial. This requires us to do the very first type of factoring that we ever learned. What was the first type of factoring? GCF. So do we have a GCF on number 12? Yes. What is that GCF? 9. If we pull out a 9, actually, is that the only thing? Just 9? And a Z. So let me make some space here. 9Z is our GCF. And what would we have left on the inside? 4Z squared minus 1. Now, ladies and gentlemen, if we zoom in and focus in on the blue binomial right there. I know we're not used to this, but isn't this a perfect square term? And isn't the number 1 a perfect square term also? Right? I mean, we're not used to dealing with 1, but you know, the square root of 9 is 3. Why? Because 3 times 3 is 9. The square root of 1 is 1. Why? Because 1 times 1 is 1. So technically 1 is a perfect square term number also. So we really do have a perfect square binomial. 2 terms, perfect square. So we could factor that perfect square binomial on the inside by taking the square root of the 4z squared. And what's the square root of 4z squared? 2z. So you put 2z on the first part of both binomials, and then you go to the number over here and you take the square root of that. What's the square root of 1? 1. So you put the 1 on the second part of both binomials. Now you need to determine the signs. And how do you determine the signs? You always look at your middle value, the b value. Now obviously, what's the b value here in blue? 0. It's not there. So you know you need them to cancel out. So one has to be positive, one has to be negative. Now let's not forget about that original GCF we pulled out. So bring down that 9z. And this is what we call completely factored. That's a factored form right there. So, I mean, some of them you will be able to see a perfect square term. Like right here, this is a perfect square binomial. right? Number 6. We could do the square root of the first one, and we could do the square root of the last one, and we will be able to plug it into our answer format. So what's the square root of 36g squared? 6g, right? The square root of 36 is 6, and the square root of g squared is g. How about the square root of 49h squared? 7h. So you put the 7h there, 6g there, 7h there. Now, once again, this is a binomial. That means that the middle terms canceled out. So how about those signs? A negative and a positive. Or you could do a positive and a negative. Doesn't matter. As long as they're different, that's the only way to get those middle terms to cancel out. So those were perfect square binomials. And that was all on this worksheet 8.8 that we had 2 days ago. Now, yesterday, we did worksheet 8. Or today, we're actually doing worksheet 8.9. Actually, we got 8.8 yesterday. Today, we're doing 8.9. Now, the difference between 8.8 and 8.9 is 8.8 was dealing with perfect square binomials, and 8.9 is dealing with perfect square trinomials. So, on number 1, we need to determine if this trinomial is a perfect square trinomial. And if it is, we have to factor it. So what do you guys think about number 1? Do we have a perfect square term in the front? Do we have a perfect square term in the back? Okay, so what we automatically think, because we have a perfect square term in the front and in the back, we could attempt, whoa, what happened there? What's going on? Hold on a sec. We could attempt to plug it into our answer format and do the square root of m squared, that's just m. And you could do a square root of 64, that's just 8. Okay? And since all the signs are positive and I have a trinomial, I definitely don't want these to be opposite because that would get rid of the middle term. So you need these to be the same. They're either going to be plus plus or minus minus. What do you guys say? Plus plus, obviously. So let's put a plus and a plus. Now, when we do this, we're supposed to check and see if it actually works, right? M times m is m squared. M times 8 is 8m. 8 times m is another 8m. 8m plus 8m is the 16m that we have right there. 8 times 8 is 64, so it really does work. This first one, is it a good idea to do these perfect square, to do the square roots on number 1? Is it a good idea to do the square roots on number 1? It's not the best. What's the best option? To recognize that the a value is 1. So then you could just say, okay, what times what is 64 that if I add together 16? Oh, 8 times 8 is 64. If I add it together, it's 16. And that's why we get this answer. By the way, since that is the answer, I'm not sure if the back of the book or the back of the worksheet actually writes it as a binomial squared. They might write it as m plus 8 to the second power. Could you guys check that? They do, to the second power? Okay. So it's the same thing. I'll accept either one. But if you're looking at the back of the worksheet, they will write it as a binomial squared. Okay, so number 2. What do you guys think? Is that a perfect square? Yes. Quadratic trinomial? Yes. Okay, so, I mean, it seems like it is so far. The only way you could be absolutely positive is if you distribute and check your answer and see if it actually works. But so far, we have a perfect square term here. We have a perfect square term back here. So it looks like we're able to factor it. The square root of 9r squared, what's that? 3r. And what's the square root of 1? So we have a 3r and a 1 on both. Now, what would happen if I put a plus right here and a minus right here? What would happen? The middle term would be 0. It would cancel out, right? And we'd have a binomial. But we don't have a binomial, we have a trinomial. So we know that we can't have opposite signs. They either have to be plus plus or minus minus. And if we take a second and look at the middle term, that's a minus. Obviously, the only way we're going to get a minus is if we have minuses right here. So this is our educated guess. And let's see if it actually works. If I go 3r times 3r, what do I get? 9r squared. 3r times negative 1, what do I get? Negative 3r. All right, let me actually show my work here. Okay, 3r times 3r, that's 9r squared. 3r times negative 1, that's negative 3r. Negative 1 times 3r, that's another negative 3r. And negative 1 times negative 1, that is positive 1. as you can see, these middle terms, what happens? They combine to give you that middle term that you have above. So you're absolutely positive that you got this correct answer, factored form. Now, this is really a great option because if you didn't know about this trick of taking the square roots, you'd actually be forced to do that long process of A times C, right? 9 times 1, oh, that's 9. And then you think of the multiples of 9 that combine together to give you the middle value, -6, right? And then you take that pair of numbers and you plug it into the answer form, right? It's a multi-step process. So this new section is really great when you have a perfect square term in the front and a perfect square term in the back. How about number 3? So far, it looks like we have perfect square terms. So it looks like it's a perfect square term, a perfect square quadratic trinomial. So what is the square root of 4y squared?
2y.
2y. What is the square root of 25? 5. So we put 2y and 5, 2y and 5. How about these symbols right here? Minus and minus, right? That's the only way we're going to get a minus in there. If we had plus plus, that would be a plus. And if we had a plus and a minus, then there would be no middle term because they would cancel out. So we're going to put a minus and a minus. Now let's just double check it. 2y times 2y, 4y squared. 2y times -5, -10y. -5 times 2y, -10y. I could already stop right there because I know that these middle terms really do combine to give me that -20y. So I know that I factored it correctly. Yay? Okay, cool. I was figuring that one of these wouldn't work. Let's check. Probably 4. Let's see. Let's do the square root of this and the square root of that and plug it into our answer format. So what's the first term on my binomial? What's the square root of 16p squared?
4.
4 what?
4p.
4p. Okay, and how about the square root of 9? 3. So 4p and 3. And what symbols belong in there? Plus, plus. Now this is going to work also. Okay. Well, anyways, you guys get the idea, right? So you're either going to have perfect square term quadratic trinomials like number 4 right here. And again, it's very important that you check your work. Okay, number 5 does not work. So let's look at number 5. So this is why it's important to check your work. We do have a perfect square term here, a perfect square term there. So a lot of us think, oh, let's just square root it, plug it into our answer format, and we're done. I guarantee you somebody's going to make a mistake and write the answer 5b with the 4, 5b with the 4, and then put minuses right here and put that as the answer and not check it. And it's going to be wrong. Okay? Why? Because when we check it, 5b times 5b, it really is 25b squared. 5b times -4, that's -20b. And then -4 times 5b is -20b. And -4 times -4 is +16. And when we combine these two middle terms, we'll get -40b. And this is definitely not -40b, it's -4b. So this did not work. So right there, we could try other methods, but I would just say prime. Okay, so in the back it says no, as in it's not a perfect square trinomial. We already knew it's not a perfect square trinomial because that middle value would have to be -40 in order for it to be a perfect square trinomial. Okay, so that's what section 8.8, 8.9 is all about. I did want to mention maybe like number 4 back on worksheet 8.8. Now, is this a perfect square binomial? You have a perfect square term here, perfect square term there, right? Okay, so our answer is going to be what? What's the square root of 4x squared? 2x. How about the square root of 25? 5. So you have a 2x and a 5, 2x and a 5. Now what symbols belong in there if it's a binomial? a plus and a minus for the middle term to cancel out. But that's wrong. Because if you check this work, 2x times 2x, 4x squared, 2x times negative 5 is negative 10x. Sorry about that. And then positive 5 times 2x, that's positive 10x. And then positive 5 times negative 5 is negative 25. And we know that that's not a negative 25, it's a positive 25. Does that make sense? So this does not work. What do we say right there? Prime. So when we're looking at perfect square binomials, you have to have a minus sign between them, guys. So like let's say I had, give me a perfect square number, any perfect square number. 16, x to the second, and give me another perfect square number. 25. Okay, so if I have 16x squared plus 25 and I ask you to factor it, what are you going to say instantly? 4x. No. You're going to say prime. Why? Because there's a plus sign right here, guys. The only way that it would work is if it were a minus sign, right? Okay, so like let's say I had 9x squared minus 16. Okay, right there you can do it. You can do it. The square root of 9x squared is 3x. The square root of 16 is 4. So 3x and 4 are the two terms in our binomials. And we know that one has to be a plus, one has to be a minus. That's the only way that the middle term will cancel out. And at the end of it all, a positive 4 times a negative 4, that's what gets us a negative 16. So if it's a plus, you automatically say not factorable. Now this type of question will pop out on the test Friday. So please make sure that you understand that. So I'm going to give you the rest of the period to work on worksheet 8.9. Go for it.